So at point A, we have the force going down, that's 80 pounds. Then you have the cable coming in, and we're going to take that in tension. So you'll have two end forces, two, which is the TAB and TAB. So the point is connected. You're going to have another tension. We call this as TAB. Then the angle here is going to be same as the 60. Then you have the spring coming in, and that's going to be in tension 2. So both end forces here will be, let's say, Fs and Fs, which means that it's going to be another force here, Fs. And we need this angle. I mean, if you want to write the equations for the force, then you would need this angle phi. So we go back to the triangle we were working with. I mean, here, see, if this is 60 degrees, the same angle here. This angle is phi, then this angle will be same as phi, which means this angle will be phi. So now we go back, we use law of sine. So sine phi, the angle we need, the side opposite that is 2. Then we got this length, we just found this length. That was square root 12, and the angle opposite that was 60. So from here, let me see if we can get sine phi as 2 sine 60 is square root 3 over 2. And you're going to divide this by 12, that's 2 square root 3. So this gets cancelled, this is cancelled, this gets cancelled, and we get sine phi as half. If the sine phi is half, your angle is going to be 30 degrees. So this angle here comes out to be 30 degrees. So now we have enough information to find the force Fs. So we're going to write two more equations. That means we're going to sum the force in x direction. That should be 0. So again, you're going to have one component going this way. You have a component going this way. So we get negative TAB cosine 60, that's the x component, plus Fs cosine 30, and that goes to 0. Then you get the sum of the force in the y direction, that should be 0. So now we're looking at the component TAB sine 60 plus Fs sine 30. Then you have the force going down, so that's negative, and that adds up to 0. And since we only need the force in the spring, so from here I could say that TAB is Fs cosine 30 over cosine 60. We come back here, put those two together, that means you have Fs cosine 30 over cosine 60. Then you have sine 60 plus Fs sine 30 equals 80. Or Fs would be, say, cosine 30 is square root over 2, sine 60 should be 1/2, and sine 60 should be same, it should be square root 3 over 2, plus sine 30 is half, and that goes to 80. So you get 3 over 4, so that's going to give you Fs 3 over 2 1/2 80, or you get Fs as 3 plus 4 is 2, so it's 40. That gives you the force Fs. So go back to the very beginning and we start looking at delta elongation. Means how much the string got stressed when you applied the force. And that should be 40, the spring force Fs, divided by the spring stiffness, which was 50. So that comes out to be 0.8 feet. So your original length, or the unstressed length, would be the new length, which is square root 12, minus this, which is 0.8. And that should come out to be 2.66 feet. So that gives you the original length for the spring, and you can see that the solution is now straightforward. You need to go through first the geometry, and then you need to go through the actual equation of equilibrium to find the elongation. Okay, we're going to move on to the new article